Welcome to class. Today we're going to talk about Chapter 1, Lesson 7, Transformations in the Coordinate Plane. Okay, so transformations we're going to talk about in a coordinate plane, which is something like this, which is that X and Y axes. All right, so we have our warm-up. There's 3 different questions for our warm-up today. Draw a line that divides a right angle in half. Number 2, draw 3 different squares with 3, 2 as one vertex. And then number 3, find the values of X and Y if you have the ordered pair 3, comma negative 2 equals X plus 1, Y minus 3. All right, where's my friend? Oh, here's the pause dragon. Remind you, it's time to pause. Work out those 3 warm-up problems, and then come back and we'll talk about them. And then press play, right? And then we'll go over them. All right, we're back. So the first one says to draw a line that divides a right angle in half. So there's graph paper, which is really, really nice because a right angle is the same thing as 90 degrees, right? So, yeah, here's my little right angle here. It's a right angle, so I'm going to put that little mark. That little mark means that it's a right angle, okay? And then what do? It says draw a line that divides the right angle in half. So I'm just going to draw a line, well, maybe in a different color. How about, we'll go with kind of maybe a blue. And it just divides it in half like that, where this side of the angle is congruent to this side of the angle. They're both the same. Okay, perfect. So you should have something like this. If you don't, go ahead and change your answer. All right, let's go ahead. So it looks like this. The number 2, draw 3 different squares with 3, 2 as one vertex. So remember, this is the X and this is the Y. So the point 3, 2 would be right here. 1, 2, 3. This is the X direction. It's positive, so you go positive. Remember, this is the X axis. This is the Y axis. These are all in ones. 2, 3. Okay, and then 1, 2, and then negative 1 over here. You know what I mean? Negative 1 down there. All right. So 3, 2. So that means the X is 3. So we go positive 3, 1, 2, 3. And then the Y is 2, up to 1, 2. So this is the vertex right here. We need to draw 3 different squares. So you know squares, they all have the same length, right? So I think I'm going to draw one here. One square could just, you know, be right here. This could be one. This is going to be a little bitty square. All side length of 1. Okay, that would be one square. We could have another square here. I could make this one with the vertex. So the vertex is right there. Maybe this will have side lengths 2 right here. Right there. Right there. And right there. And then another one could, you know, let's do 4. Why not? Okay, so one side length's 4 for the square. So it's right there at the vertex. It has that side length. And then, you know, 1, 2, 3, 4 this way. And then 4 here. And 4 here. So there you go. Draw 3 different squares with 3, 2 as one vertex. 1, 2, 3. Okay, cool. Let's move down here to number 3. Says find the values of X and Y if 3, negative 2. So this is the X and this is the Y. And then they're giving us a little kind of like little formula here to do. So what we have is we have find the values of X and Y. Oh, it says X and Y equal this. So this equals this. Okay, so this is it. It wants us to know what X and Y are. So this means that this equals this. That's what that means. And this, it's kind of like we were doing that midpoint thing. This right here equals this, okay? Just ignore what I wrote right there. Just ignore that, all right? So what that means is that we have 2 equations. 3 equals X plus 1, and negative 2 equals Y minus 3. So we're just going to use our algebra, right? So we would try to solve for x. We're going to use the inverse operation to get it by itself, which is the inverse operation of addition would be subtraction to both sides. 3 minus 1 is 2 equals x, and then I'm going to use that symmetric property of equality. So x equals 2. All right. Now we want to get y by itself. Right now y is being subtracted by 3. We got to get rid of that negative 3. So we're going to do the inverse, which would be adding 3 to both sides. And we get negative 2 plus 3, which is 1, equals y. And then symmetric property of equality, y equals 1. Boom. Those are the two answers. If you did that right, great job. Perfect. And over here on this, I didn't say that, but we could have a variety of different answers, okay? You just need to make sure that that point is on the vertex. So it's the vertex is the corner, okay? It has to be in the corner. That's what a vertex is. And you got to have 3 of them. I mean, they could all be the same side length. I made mine different side lengths. They could be the same. It just, you just have to draw 3 different squares in different locations. Okay, so that's the warm-up. So let's go ahead and move on here to talk about some vocabulary. So the first thing is transformation, which is what all this is about. This is about transformations in the coordinate plane. Okay, boom. What are transformations? So transformations, that is a change in the position, size, or shape of a figure. A change in the position, the size, or the shape of a figure, that is a transformation. Okay, so you're starting with something, and then it changes, right? Either the position changes, the size changes, or the shape. That's what a transformation is. Now, whenever you're dealing with transformations, you have pre-images. And that is the original figure. Okay, the original figure before a transformation. That is called the pre-image. And then there is an image. An image is the resulting figure after a transformation. Okay, so this is basically where you start. I'm going to write it right here. Where you start is the pre-image, and where you end is the image. So start, and this is end. Okay? So start, pre-image, goes to, and they use this arrow right here, to what you end with, which is the image. So here, this is that you're going to use symbols, all right? And so it's very important that you know how to read these symbols and write them. So this is the pre-image right here. This triangle right here. So pre-image right here. So we have this triangle, and these are the vertices, okay? And that's where we start, and that's how you write it. You write it as triangle ABC. This is the pre-image, and then this indicates there's a transformation. That's what that arrow is. The arrow is the transformation. That's what that means. And then what you end with, so this is the transformation. There's some type of transformation. And then you end with the image, which is here, which if you notice, the image has this other notation on the vertices. It's an A with a little tick mark up there, and a B with another little tick mark up there, and a C with a little, or like apostrophe, right? Would probably be better. And then what we say is that this is where it goes. So we started here at triangle ABC, and then we did a transformation and ended up at triangle A prime, B prime, C prime. Okay? So that is the notation. You got to be able to do that. Okay, let's go ahead and talk about some actual transformations. So the first transformation is a reflection, okay? So a reflection, what a reflection is we start here, right, ABC. That's where you start. That's the pre-image, and then it gets reflected across this y-axis, and then it becomes A prime, B prime, C prime. What's important is that all of these vertices, when they get reflected across a line, they're the same distance from that line. So if you look at A is from this line, it is 1, 2, 3, 4. Let's just call that, well, it's more like a half. Okay, so 1, 2, 3 and a half. So that means from this line, that means A prime has to be 3.5. The distance has to be 3.5 over here. So let's see, 1, 2, 3.5. That's right. Okay, what about B? B, how far is B from this line? 1, 2. Well, that means that B prime has to be the same distance, 1, 2. Okay, what about C? C is 1 from this line. C prime is 1 from that line. Okay, so a reflection or a flip is a transformation across a line called the line of reflection. So this line right here has a special name. It is called the line of reflection. Each point and its image, so each point and its image, so like A is the point, A prime, remember image is the end, so each point and its image are the same distance from the line of reflection, which is what we talked about. So that's a reflection. Let me show you a different reflection. So one year a student made this for me. This is a reflection of the Wonder Woman symbol. I'm trying to get it in the screen. So if you see here, this is the line of reflection, and here's the symbol here, and it was, everything was reflected over this line here. I wonder if I can do it sideways, if you could see if I change it. Yeah, you can see it there. So it was reflected across this line. And they did this using a compass, and they did it really technical. Yeah, that's a reflection. Okay, let's move on to the next one. Very, very good. Okay, the next one is a rotation. So a rotation, let's try to see where we're starting. We're starting here with this quadrilateral, right? Four-sided figure. And it is being rotated, and we can tell because it's just, all of the vertices are just letters. And it's being rotated, which looks counterclockwise to this image where you can tell all the prime symbols are, so you know that this is the image. Okay, so it's moving counterclockwise. Like a clock goes this way, but it's going counterclockwise. So a rotation or a turn is a transformation about a point P. So this is the point P right here, okay? And it's being rotated about that point, okay? And it's being rotated by an angle. And a lot of times what you can do is you can take this, and if you draw a straight line from G to the point, and then you go where it rotates to G prime, right there, this angle right here has a measure, right? And that is the angle of rotation. This is the angle of rotation right there. I'm going to point arrow right there. Angle of rotation. And we could figure out what that angle of rotation would be if we just pulled out our handy dandy little protractor here. To me, if I'm just going to estimate really quickly, I line this up. Or wait, maybe let me line it up a little bit better on this line. There it is. Yeah, it really looks like it's about 60 degrees. So this is a 60-degree rotation counterclockwise about this point right here. And so there's a couple things. There's an angle of rotation, so each point is rotating 60 degrees counterclockwise, but also the point's distance is the same. So G right here from this point is 1, 2. It's 2 lengths away from this point and the center of rotation. And G prime is also, well, it's the same distance, but it's hard to see 1, 2 because it's at an angle, so you can't really see on this graph paper. I mean, we could calculate it using the Pythagorean theorem that was 2, but, you know, we're not going to do that right now. So I just need you to understand that it's the same distance away. So a rotation or turn is a transformation about a point P, right there, point P, called the center of rotation. So this is the center of rotation, point P. Point P is the center of rotation right here, okay? Each point and its image are the same distance from P. Yeah, we just talked about that. So point G and its image right here is the same distance from point P. Okay, rotation. Let's look at a different rotation. This is one that a student made for me. A rotation of a fruit tree. I planted a bunch of fruit trees one year. I have a bunch. They're still young, haven't quite started producing a whole lot of fruit yet, but I'm hopeful. Okay, so anyways, I talked about fruit trees in class, and so this student made a picture of a rotation of a fruit tree for me. So here we go. If you look, this fruit tree, it's starting here, and then it's rotating over there about this point P. So just a picture showing the rotation. So it's here, and it just rotates that way. All right, perfect. So let's go ahead and talk about the last one, which is a translation. So a translation or a slide is a transformation in which all the points of a figure move the same distance in the same direction. So here we start here at J, M, L, K, and all of the points are sliding in the same direction, the same distance. That's what a translation is. So it starts here and it just slides over there, okay? Translation. A student, I kind of like Starbucks and I like hot chocolates, but they made a picture of a translation of a frappuccino. That's still kind of cool. So if you see this, it's just this frappuccino's here and it slides over there. That's just a translation, okay? It's here, slides there. That's a translation or a slide. Perfect. Okay, let's go ahead and look at some problems and what they look like. So this problem 1A says identify the transformation, then use arrow notation to describe the transformation. So I want to go back to our previous page. And when it says use arrow notation, this right here, go ahead to your notes and circle this. This right here, this is called arrow notation. That is arrow notation. All right, that's what it is. Okay, this triangle ABC, transformation triangle A prime, B prime, C prime. So it says identify the transformation. Okay, so we have, where are we starting? Right here, A, B, C. And then what's happening? It's going A prime, B prime, C prime. So is it a reflection? Is it being reflected about the y-axis or the x-axis? I don't think so. Is it being rotated? Yeah, it looks like it's being rotated. It doesn't look like it's translating because it would be in the same thing. So this looks like a rotation. So let's see. I like to the center of rotation would be 0, 0. So if I take A, and I always like finding out what the angle of rotation is, and I take A and I draw a line from A to the center of rotation. And then I draw a line to A prime here to the center of rotation. What type of angle does that look like? Yeah, that looks like a 90-degree angle. Okay? And then I could try it again with B. Let me try it again, because it should be the same angle for everything. I'm going to use a different color. So B is right here. So if I draw a line here, from B to the center of rotation, I have this line here, and then I go to B prime, it should be the same angle of rotation. Does that orange look like 90 degrees? Yeah, it does. What about the pink? Let's try C. We'll go pink. So we draw a line here from C to the the center of rotation, and then we go from C prime to the center of rotation, and that pink angle formed also looks like it's 90 degrees. Okay, so what it looks like is that it's rotating 90 degrees, and we start here and we're going this way, so it would be counterclockwise around the point 0, 0. So this is a rotation, a counterclockwise a rotation counterclockwise 90 degrees about 0, 0, which would be the center. Okay, so that would be describing that rotation. And then we have to use arrow notation. So we're going to say we start at triangle ABC, and then it rotates. It's that transformation, right? To triangle A prime, B prime, C prime. There we have the description of the transformation and then the arrow notation. So that's it. Okay, let's look over here at example 1B. So what do we have here? It looks like, okay, there's the prime, so we know that that's the image. So this is the pre-image. This is what we start with, and then something happens and we end up with this. So what is happening? We have D, E, F, G, and then we have G, F, E, D. So this to me looks like it's being reflected across the x-axis. If you look, G here's one away, G prime's one away, F is one away from the x-axis, F prime is one away, D is 1, 2 away from the x-axis, and D prime is 1, 2. So it's the same distance. And lastly, E is 1, 2, and E prime is 1, 2. So this would be a reflection across the x-axis. Okay, that's the transformation that's happening. And then we just need to do the arrow notation. So I'm going to use this little figure right here, and I'm going to call this DEFG. So looks like it's a rectangle DEFG. So you have to go in the order DEFG. You can't just go DFEG. You can't do that. It has to be in the order around the figure. So DEFG transforms, it reflects to rectangle D prime, E prime, F prime, and G prime. So that is the answer right there. All right, perfect. So, ladies and gentlemen, now it is your turn to try this, check it out, example 1. So I want you to do A and B. Identify each transformation and then use arrow notation to describe the transformation. So here's my friend the pause dragon reminding you to pause. When you get done with this problem, A and B, press play, and then we'll go over the answers together. All right, see you in a bit. All right, we're back. Let's look at A. What's happening? Well, we know that there's the primes here, so that's the ending. We're starting here. M, it looks like it's going there. P is going there. N is going there. And O is going there. So it looks like everything's just sliding or shifting. So that is a translation. Okay, so that's what we say. It's a translation. And then we just need to use arrow notation. So we're going to say this is a rectangle. So rectangle, M-N-O-P, transforms, but it translates to M prime, N prime, M prime, N prime, O prime, P prime. So if you got that right, woo, great job. Okay, perfect. Let's go over here. We're starting here, X, Y, Z, and it's transforming over here. So X is here and X prime's here, Y is here, and then Y prime's over there. So it doesn't look like it's being reflected, and it doesn't look like it's being translated. So this is definitely a rotation. That's not rotation. There we go. Rotation. And it looks like it is rotating this way. So I would say that this is a it's rotation, and it's counterclockwise. That's all I can say about this right now. And we're going to do the arrow notation, which means that triangle XYZ is going to triangle X prime, Y prime, Z prime. Perfect. All right, I will see you back in a little bit for example 2.